All right, 11.4 is over inscribed angles. The objectives are to find the measure of an inscribed angle and to use inscribed angles and their properties to solve problems. There's your vocab. All right, so an inscribed angle is your first buzzword, and it's an angle whose vertex is on a circle and whose endpoint, whose sides contain chords of a circle. So basically, there might be a diagram on the next slide. If this was your circle, this blue angle is an inscribed angle because it's on, the vertex is on the edge of the circle. So because the angle of the vertex is on the circle, it's called inscribed. An intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points of the inscribed angle between them. So this is the intercepted arc. A chord or arc subtends an angle if its endpoints lie on the sides of the angle. And we'll see some things like that are here in a minute. But it's basically just the intercepted arc. For this example, so this is the diagram that you would have down, inscribed angle theorem. Go ahead and draw this diagram out. The red angle is the inscribed angle. The blue arc is the intercepted arc. And so DF subtends angle DEF. This is just, subtends is like a verb. It's basically just says these are paired up together. An inscribed angle has an intercepted arc, and where the arc subtends is basically, it just means where they touch, at D and F. So here's the theorems for it. Make sure you get down these three different cases because they do look differently. Notice how this first case, it goes through the point, so this is a diameter. This one, it surrounds the point, and this one, it doesn't, the point's not inside, the center's not inside, which is still fine. You still do the same rule for all of them, which is nice because it just keeps it simple. Basically, the red angle is half the arc. If they give you the measure of this, you can find this by just taking half of it. If they give you this, you can find this by doubling it. So if they give you the arc, you half it to get the angle. If they give you the angle, you double it to get to the arc. I would write that down along with the diagram and the equation. All right, so let's do this example. They want us to find the measure of PRU. Well, I know that angle PRU equals 1/2 of the arc that it subtends. So since this PRU is right here and it subtends this arc, you just find half of this. So put this into the equation. You have 1/2 times 1/18. So you get 59. So the measure of angle PRU equals 59 degrees. All right, now let's find the arc PS. Well, it's the same thing but backwards. On the first one, they gave us the arc, we had to find the angle. This one, they give you the angle, you need to find the arc. So I know that measure of angle PRS equals half of the arc that it subtends. So again, notice it's the same equation. The angle equals half the arc. Here's the angle, here's the half, here's the arc. Now though, I'm going to put in 27 on this side because that's the angle measure. All right, then I'm just going to solve for this by, since I have 1/2, when I multiply 1/2 to get rid of it, I can multiply it by 2/1 because it gets rid of the 2's. Multiply it on this side, I have to multiply it over here. And this becomes 54. Okay, so that's all you have to do. These problems on the last section or the second section, this the idea is they gave you the center angle and it was the exact same as the arc. Now they're giving you an inscribed angle and you take half of it. All right, so here's this corollary. Corollary is just basically like a theorem. And what this is saying, if these three angles, the red angle, the blue angle, and the green angle, since they all go to the same arc, they all have to be the same. So let's say this was 100, that means this would have to be 50. And since this doesn't change, this is still 100, this would be 50. If this was still 100, this would be 50. So red angle, blue angle, and green angle all would equal the same. So that's basically the idea here. If multiple angles subtend the same arc or they intercept the same arc, they're all going to be congruent. All right, and then your next theorem, an inscribed angle subtends a semicircle if and only if the angle is a right angle. So when the angle subtends at the diameter, it becomes 90 degrees. Because if you think about it, this diameter cuts off at 180 because the whole circle is 360. Since the whole circle is 360, and from here to here is 180, that means that this angle, if I took half of this, it's going to be 90. So it's always a right angle. All right, so find A. This is the example that they want us to do. I believe it's actually example 2. It says 3A. That's a lie. All right, so they want you to find A. But since I know that it subtends the diameter, I know that angle Z is a right angle. So angle Z equals 90 degrees. But angle Z, they're telling me, is 5A plus 20. So all I do is set 5A plus 20 equal to 90. And I'm doing that because it subtends the diameter. Because it intercepts the diameter, that's where it intercepts at, this has to be 90. Let me do a little solving, subtract my 20. 5A equals 70. Divide by 5, divide by 5. A equals 14. Am I done? I am done because all they did is ask for A. They didn't ask for this angle, Z. They didn't ask for W, Y, or X. They just asked for the variable A. We did that. All right, this angle. Finding angle measures of inscribed triangles. So this is basically the multiple inscribed angles theorem. Since M goes to J and K, or no, wait, sorry. I'm reading this backwards. Since K goes to L and M, so I'll trace this in red. Here's the arc that we're looking at. This angle goes to that arc, and this angle goes to that arc. So since these are the same, I would take, if I knew the measurement of this one, say it was 30, I would take half of it and get 15. Take half of it, and this would get 15. So they would be the same. So angle J is congruent to angle K because they intercept same arc. So all I have to do is take J and equal it to K. So I got 5B minus 7 equals 3B. I'm going to subtract 5B from this side. I want all my variables on the same and all my non-variables on the other. All right, so I get negative 7 equals negative 2B. Divide by negative 2, divide by negative 2. I get B equals 3.5, which is cool and all, but they want to know what angle LJM is. So I take LJM was 5B minus 7. Put in my 3.5. This becomes 17.5 minus 7, which gives me 10.5. So angle, measure of angle, LJM equals 10.5. Now what I can do to make sure that I did this problem correctly is that I can plug it back into angle K and see if I get the same answer. Because they subtend the same arc, they should be. So if I take 3 times 3.5, I do get 10.5. So I did this correctly. They should come out to be the same. It's not a coincidence. It's supposed to be. It's fate. It happens. All right, next theorem. I think this is your last one for this video. It is. All right, so let's get this down real quick. Because this quadrilateral is inside the circle, it's still, these angles all still have to add up to 360. But the cool thing about this is that it subtends when they form a quadrilateral, the opposites equal 180 if you add them together. So A plus C is going to be 180 because they're opposite. D plus B equals 180 because they're opposite. All right, so let's do this example. They want us to find the angle measure of GH, find all the angle measures of the quadrilateral. So the first step is let's find B. So I've got four pairs of angles. K, J, H, G. K and H are opposite in a circle, so they're going to equal 180. But I don't know what H is, so that's not going to help me. I do know what these two are. Angle J plus angle G is going to equal 180. That's the theorem that we just looked at. Because they are inside the circle, four angles inside a circle that form a quadrilateral, the opposites are going to be supplementary. So they equal 180. So all I have to do is I'm going to plug in what J was. J was 6b plus 20. G was 3b plus 25. And that's all going to equal 180. All right, let me reduce, simplify. 6b and 3b become 9b. 20 and 25 become 45. And I still have the 180. All right, solving, I get 9b, subtract the 45 over, gives me 135. Divide the 9, b equals 15. All right, so I got b, but they want to know all of the four angles. So all you have to do now is just plug them back in to each angle. So let me do J first. J, I've got 6b plus 20. Put in the 9. Or 15, sorry. 9 was from earlier. Put in the 15 here. This becomes 90 plus 20, which becomes 110. All right, so I got one angle. Now let me do G. Angle G was 3b plus 25. Put in the 15. I get this to be 70. All right, and notice what happened here. I found G, or J, and I found G. One was 110, one was 70. These add up to 180. So I did it correctly. That should happen. Now let me find K. Put this over here. Angle K equals 10b minus 69. 10 times 15. Equals 81. So angle K is 81. Now I have to find angle H. Well, I don't know an equation for angle H, but I do know that these four angles all have to add up to 360. I also know that K and H have to add up to 180 because they're opposite in the side of the circle. So K plus H equals 180. I just put in the 81. Angle H equals 99. Okay, so here's my four answers. Whoops. Again, they're asking, always make sure you're answering what they're asking. Don't just put b equals 15 and be done with it. Find the angle measures of G, H, J, K. 110, 70, 81, and 99 are the measures of each angle. So you have to make sure you're doing what they're asking.